Good morning, students. This is Shivraj Patil, and welcome to Maths Chef YouTube channel. So, this is the continuation class for the yesterday class, coordinate geometry. Yesterday we discussed the distance formula, and section formula. Distance formula, what is the d is equal to square root of x square plus y square. Section formula is x y is equal to, means dividing the line segment in the m ratio, m x2 plus n x1 divided by m plus n y m y2 plus n y1 divided by m plus n externally, and xy is equal to m x2 minus n x1 divided by m minus n. Similarly, m y2 minus n y1 divided by m minus 1. Okay, sir. This is the internally, this is externally, and the midpoint formula is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. And last one is what? Centroid. Centroid, the point of intersection of the all medians. Centroid, OID is equal to what's x1 plus x2 plus x3 divided by 3 y1 y2 y3 divided by 3. Yesterday we have derived these formulas. So today we will discuss about the incenter of a triangle. Subtopic today topic is incenter of a triangle. What the incenter is? Incenter. Center of a, is it, triangle. In the center of a triangle. Centroid is the point of intersection of the medians. The incenter is the point of intersection of at least two internal bisectors. Point of intersection of at least two internal bisectors. This is the triangle. This is the one bisector. Okay, one bisector. Another one is another bisector. Okay. So this point I is called. This point I is called incenter of the triangle. Incenter of a triangle means we can make the center, okay, inside the triangle. In center means you can see for this radius you can make the triangle like that. This becomes the center of the radius, center of the circle with radius. Okay. Then center, that's okay. For the centroid meaning is, this is important. This is cuts the midpoint formula. Okay, sir. The line segment from the vertex to the opposite part cuts the opposite side in exactly midpoint. So this is, okay, sir. For this is, and okay, and here the property. Okay, sir. Property cuts the line segment to 2:1 ratio. 2:1 ratio. So let's derive the formula for the incenter of the triangle. Incenter of a triangle. The definition is, what is the incenter? Definition is point of intersection. Okay, so point of intersection of at least, okay sir, at least, okay sir, two Point which refers to internal bisector of a triangle. Internal bisector of a triangle. Is it? The point of intersection of any two internal bisectors of the angles of triangle is called incentre of the circle. Any two, okay sir. Any two of the internal bisector. Any two of the internal bisector. Okay sir. Two of the internal bisectors. Rhetorically, okay. This is bisector means making the angle. Okay sir. This is very important. This becomes this, okay sir. Let us consider here. This becomes this, okay sir. This is the I in center. Okay. So the picture is mentioned. Let's draw the formula for this one. Okay sir. Let's derive the points, okay sir. Let's find the point, the incentre of the, okay sir. Incentre of a triangle. Points, which means the triangles are the given points, na? The given points. Then where the incentre, okay sir. What do you call? Okay, find the point of intersection of the bisectors. Incentre is the point of bisector. Then okay sir, the basic condition is one angle is there, okay sir. If in the geometry you know, in geometry you know, this is A, this is B, this is D, this is the internal bisector, okay sir. This is the internal bisector. If angle is A and D, AD is internal bisector, okay sir. Internal bisector then okay sir, then this condition, okay sir. BD by BC formula is there. BD by BC is equal to AB by AC. Okay sir. I am going to use this formula to derive the point for the incentre of the triangle. Derive the equation, okay sir. Point of the incentre of the triangle. BD by BC is equal to, means this by this is equal to this by this one. Very important. Yeah. Also, the exam is okay. First one. Just see this is the useful formula for multi times you are using that one. Okay. Let's take the triangle with the sides. The side A1, A is x1, y1, B is x2, y2, and D is x3, y3. With respect to, okay sir, A, B, C, okay sir, this is the whole length is called A and the D is C. So sir, this the whole length is called B divided by B and this is C. And the internal bisector, one internal bisector it divides, okay sir, at point E in the form of C is to B ratio. First part of the derivation, okay. By section formula, the point at D we can derive by section formula. C is to B, or the D is equal to next first C again. The incentre is the BI, Makel angle. This becomes I. And we first find out the midpoint formula. Okay sir. Section formula for the point at D. This is, okay sir, mx2. This is cx3. cx3 plus bx2 divided by c plus d, c y2 plus b y2 divided by c plus b. Okay, this is the midpoint formula. You know already. Let's take the instead of deriving this one. Okay, sir. This is the basics na. Okay, sir. See, in the triangle ABC, in the triangle ABC, AB, okay, sir. AD is a internal bisector. Internal bisector. Internal bisector. Okay, sir. By the previous formula, you know, the formula, the geometry formula, what you will get. Okay, sir. AD is the internal bisector in the triangle ABC. So then, okay, sir. BD by BC is equal to, okay, sir, AB by AC. AB by AC. This becomes, so I wrote here C and C is to B, then how it becomes, okay, sir. Just I am writing. What is AB? They given here. With the condition AB is equal to which one? C. AC is equal to B and BC is equal to A. They are the length of the opposite angles, okay, sir. Length of the opposite sides of the angle ABC respectively. Length of the opposite sides of the angle ABC, the ABC. Then AB becomes C by AC becomes B. So this implies BD divided by DC. This is the DC. Is equal to C by B. Okay, first one, a formula, first visit. Then you can find the okay, sir, the point D section formula. Here the point with the section formula, you can C into x3, C x3 plus B x2 divided by B plus C, and C y3 plus B y2 divided by B plus C. This is the section formula. Then we, okay, sir, we find you know the point this one, and we have the point x1 y1. Then should find the AI and TI. Yes, sir. To find the point I, the incenter of the triangle I, we should take the, okay, sir, you can say the ratio, the what it ratio divides DI in AI. Thus that comes. Okay, so here triangle, okay, I am erasing this one. Triangle A B D, sorry, in triangle ABD, BI is the internal bisector. BI is the internal bisector. Internal bisector. Okay, then DI, okay, DI by AI. Is it? You can consider this one as DI by AI is equal to DI is equal to BD by AB. BD by AB. This becomes, what is the BD? You have to find out the ratio. What is AB is C. di by AI is equal to BD by BD by C. Okay, sir. From previous equation we have BD by DC is equal to C by B. This is the equation 2. From previous equation 1, okay, sir. From equation 1 previous class, BD by DC is equal to C by B. Okay, sir. This I am writing. They given quite some assumptions here. They take some extra points. Okay, I am taking BC. Okay, sir. This is we want BD, na? So taking the reciprocal, DC by BD is equal to B by C. Okay, sir. B by C. This implies I am adding plus 1 on both sides. Okay, sir. This DC by B D plus 1 is equal to B by C plus 1. This is the, in this derivation, this is the quite okay, sir. Assumption only. Remaining all parts are easy. So this becomes D C plus B D divided by BD. Okay, this becomes B plus C divided by C. So what is BC DC by BD? DC by BD means again A. I am writing this one BD by A, taking the reciprocal, okay, C by B plus C. So BD gives A into C divided by B plus C. This is the distance, the length of the BD. This one BD. Then you can find out the this one, the length of the ADI by AI. This is the BD by, okay. Then this equation becomes, what is BD? AC by B plus C. Yes, sir. Something happened. See, this I should write here. What is the value of BD? AC by B plus C divided by C. Okay. Some mistakes, na? Minor mistakes. This is AC by B plus C into 1 over C. C it cancels. This becomes A by B plus C. Which one? DI by, okay, sir. DI by AI is equal to, okay, A by B plus C. This DI is the ratio of A is to B plus C. Again from the section formula. Okay, so you can derive it. This is the B plus C, this is the M, this is the N. Okay, sir. This is the En, this is the Em. Direct from section formula, you can figure out the final answer is see. You have to find out the which one. How do you find out the center of the point A? That is the, okay, sir, in between the line segment A and D. So it comes the ratio of B plus C is to in the A form. B plus C is to A form. So that's section formula. D, we have D is equal to C x3 plus B x2 divided by B plus C, and C y2 plus B y3 plus B y2 divided by B plus C. These points, and A is equal to x1 y1. Further consider, then I becomes, okay, sir, Okay, this quite important only. B plus C into C x3 plus B x2 divided by B plus C. Again plus okay B plus C. This is the point. We are confusing and this becomes x and this becomes y. Okay, you can write then. Okay, sir. Then I becomes okay, sir. B plus C into x plus okay B into which one x1. Okay, sir. Again B plus C into y plus this is A into this is A into and this is A into y1. Just simply put the value of B plus B plus C becomes what is C x3 plus B x2 divided by B plus C plus A x1. Similarly B plus C into C y3 plus B y2 divided by B plus C plus A y1. This can cancel. This becomes A x1 plus B x2 plus C x3. Similarly here A y1 plus B y2 plus C y3. Is that? I think so. No. Divided by A plus B plus C. Yeah. I missed the notation. Okay, sir. For lack of the board length, okay, sir, I'm getting okay. I'm going to reduce the equation. I'm keeping some main some concepts. Let's see. Okay, this is the M is to ratio, no? M is to N. Okay. The point I becomes here. I have to consider C plus okay, B plus C into X. I'm writing this one. This is X. Okay, sir. This is X plus A into X1 divided by okay, sir. This is C A plus B plus C. I missed this notation. Okay, sir. Again B plus C into okay, great word. Okay, this Y plus A y1 divided by okay, sir, A plus B plus C ratio. So this then becomes B plus C. Okay, this is C x3 plus B x2 divided by C plus B plus A x1 whole divided by A plus B plus C. B plus C becomes C y3 plus B y2 divided by B plus C plus A y1 whole divided by A plus B plus C. So this can cancel, this is to cancel. This whole becomes equation become then A x1 plus B y1 plus C. So, okay, sorry. B x2 plus C x3 divided by A plus B plus C. Similarly, this is A y1 plus b, y2 plus c, y3 divided by a plus b plus c. Yes, sir. Yes, sir. Only the shortage of my writing word, so I'm getting confused somewhere in between. This is the Incentre. Okay, sir. The Incentre is what? The intersection of the any two internal bisectors. Incentre is the point of intersection of any two internal bisectors. Okay, sir. See, this is also here. Yeah, okay, sir. This is also you can draw dot this one. Okay. For this also you can draw this one. You can do something. Okay. This is the Incentre. Okay. Here, one conclusion is there. Okay. What you should show? Okay, sir. By saying the symmetry. Okay, sir. The symmetry means opposites. Okay, sir. Same side. Okay. Same point. Okay, sir. The I is common for. Okay, sir. I is common for. Okay, sir. This is called D. This is called E, and it's called F. Okay, sir. Okay. I is common. Okay, sir. In center for. Okay, sir. Common center for the line segment. Okay, sir. Bisectors DI and A D. Okay, sir. Bisector for the BI, angle BI and AI and CI. I is the common intersection point. Okay, sir. That's why the all length. Okay, sir. AD and BE and CF. Okay. CF passes through the common point, single point. Passes through the single point. Single point. That's why the bisectors are concurrent. Bisectors are the interbisector of angles of a triangle are concurrent. Internal bisectors are concurrent means it should write right. Internal bisectors are concurrent. Okay, sir. What they give clearly? Internal bisector of the angles of a triangle is internal bisectors are concurrent. Internal bisectors are concurrent. Concurrent means passing through the single point. Okay, sir. Means passing through the single point or common point. Single point. Okay, sir. Once I have explained, this is the section. Okay, sir. Okay, sir. BD by DC is equal to AB by AC. So this becomes C and B. This here, okay. Okay, we derive the equation for the, okay, sir. DI by EI. That is comes under C by A by B plus C. Again, sir. Here using one formula, the internal bisector formula. Second one, internal bisector and the ratio formula. Second one is section formula. Okay. So using section formula, mx2 plus nx1 divided by m plus n and ny2 plus ny1 divided by m plus n. Using only this one, and another one is, okay, sir, BD by DC is equal to AB by AC, where BD is the internal bisector of a triangle. Okay, sir. AD is, okay, sir. AD is the internal bisector of the triangle. AD, B and C. Only using these two formula we derive this two equation. Okay, sir. I think so. The Incentre point is AX1, BX2, CX3 divided by A plus B plus C. Another one is for Y, AY1, BY1, BY2, CY3 divided by A plus B plus C. This is the point. Yes, sir. point of the incenter. Next one is area of the triangle. Area of the triangle. Next one is area of the triangle in the form of x and y in Cartesian plane. Okay, area of the triangle. Area of a triangle. Triangle in a Cartesian form. Okay. Here also should remember the triangle is there. Okay. This is the triangle. Next an A, B, and C, and A is x1, y1, B is x2, y2, C is x3, y3, x3, y3. And this is the axis. Okay, this is the axis. This is positive y, this is positive x. Only reference point I have taken. How to find the area of the triangle. Okay. Just draw this some connecting line from, okay sir, this is called O. See, connecting lines only. So we want this one. We are not taking, this is M, this is M, and this is L. We want the area of this one. Okay, area of this triangle. Before going to the find the area triangle, just area of the trapezium. Let's see the area of the trapezium. Area of the trapezium means only two sides are parallel in a parallelogram. In a parallelogram, if two sides are parallel, then it's called trapezium. Okay, sir. Then area is, okay sir, this is the height, this is the height. Okay sir, this is the length A, this also become A, this becomes P, and this becomes C. The whole length becomes D. Okay, sir. Ready-made formula already you know. Okay sir, h by 2 is equal to, okay sir, h by 2 into A plus D means 1 by 2 into height into some of the parallel lines. Okay sir. This is the derivation. Just to see the derivation is how A is equal to, okay sir, this is sum of the two triangles and one rectangle. Okay sir. This is 1 by 2 B into H plus A into H is height, area of the rectangle, again plus 1 by 2 B into C, H into C. Just take the H and 1 by 2 outside. What we left, this we have to B plus 2A. We taken 2 outside, na? 2A plus C. So this becomes H over 2. Or is, we can write this is A plus, we can write A plus B plus C. So this becomes H over 2 A. What is the A plus B plus C? D is the formula. Okay, sir. Derivation. Okay. Let B. But our motto is here to find the equation of the triangle. Okay, the area of the triangle in terms of given values x and y1. Okay. The given values x and y1. Okay. Here the area of the trapezium is 1 by 2 height into sum of parallel sides. Okay sir, parallel sides length. Here you know, okay sir, this is x2, y2, this is x1, y1. Here we have see already 3 parallelograms. Okay sir. three parallelograms. What are? Okay, sir. First one, ABNM. ABNM. Here height is, okay, sir. Height is NM. Okay, sir. H is equal to N into M, and parallel sides. Parallel sides are which are NB and MA. NB and MA. Next, another, okay, sir, another AML. AMLC. Here height is ML, H is ML, and parallels are ML and L. MA and LC. MA and LC. Similarly, another one is there. Okay, sir. This which one? BN LC. Here, what is the height here? What is the height here? LC. H is equal to LC, and the triangle is the NL. Okay. So this is the parallel. Okay. This is H is equal to N into L, and parallel sides are, okay, BN and LC. BN and LC. Okay. To know more about this one, just make, okay, this is, okay. So then you can get X3 and Y3. Okay. This is the, here how we define, okay, sir. This is, you know, okay, sir. What is NM? Okay, sir. NM is, this is x2, x1 minus x2. This point is x3 minus x1, upper side. This one. And then what we want, and NL, this is, okay, sir, x3 minus x2. This NL. So here you can write. Where should I write here? This one. And see, OB is equal to, okay, NB is equal to Y2. Just I am writing NB is equal to Y2, and MA is equal to length is Y1, and LC is equal to Y3. Similarly, after exercise this, NM is equal to x1 minus x2, and ML is equal to x3 minus x1, and NL is equal to x3 minus x2. These are assumption only, sir. Just our motto is right to trapezium into form of the height into each one, sum of the parallel sides. See, listen here. Then area becomes here. Area becomes okay, the whole trapezium. One is the whole trapezium area of the triangle is equal to, what is that? You can write the triangle is the area of the trapezium, area of BN MA, BNEMA plus AMLC okay, minus BNLC. Here triangle is, there are three. There are three trapeziums here. This one, okay, this one, and this one, and this one, and this one, and this one. So plus, okay sir, adding plus one and taking the minus of this one, we will get the this one. Okay, at a triangle. Just write the height. Okay sir, this becomes 1/2. What is the height of the BNML? Okay sir, BNML is NM. Okay sir, NM into NM into what is BN plus MA plus AMLC. What is the height here? ML 1/2 M into L. Parallel sides MA plus LC. MA plus LC minus 1/2. What is the height here? NL. Then passes NB and LC. NB plus LC. Okay sir. This is NM is, okay sir, 1/2 x1 minus x2. What is the BN? BN is y2 and MA is y1. So y2 plus y1. This is y2. This is y1. This is y3. Plus what is ML? x1/2 x3 minus x1 into MA y2 plus LC y3 minus 1/2. What is NL? NL is x3 minus x1. x3 minus x1. Then sum is NB. NB is y2 plus LC y3. Is it? This becomes, I think so, y2 plus y3. x3 minus x1. MA. This is y1. This is y1 into y3. This is y3, y1. Okay. This is y1 into y3. So this equation becomes, okay sir, after simplifying, this becomes 1/2 x1 into y2 minus y3. Thank you sir. This is the whole multiplication. x2 is y3 minus y1 plus x3 is y1 minus y3. Okay sir, just here x1 and y2 here, there x1 y2 there, and x1 and y1. Yes sir, here we will get the x1 y1 plus this one here. Here minus we will get the x1 minus x1 y1. So this get cancelled. Similarly, x1 y1, x2 y2, x3 y3 get cancelled each other. So remaining terms are x1 y2 minus 3 and x2 into y3 minus y1 and x3 is equal to y1 minus y3 is the required, okay sir, area of the triangle, the given points A, B, C, x1 y1, x2 y2, x3 y3. And there given. And okay, anyway, the area of the triangle is almost, okay, absolute value. Okay, the area of the triangle is always an absolute value. Then Then for the formula, if you take the mod of the formula to derive the equation, the given the area of the triangle. Okay, instead of writing this one, area of the triangle, okay, area of ABC. Okay, triangle ABC is the module. Okay, module, because this is this one. So we can write 1 by 2 x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Okay, this is the mod, because the absolute value, area of the area always is positive value. Okay, then they given collinear points. Okay, sir. Collinear. If the points are collinear, if A, B, C are collinear. Collinear means, okay, sir, the slopes are in the same point. Okay, sir, this is the point, this is the point, this is the point. Collinear. Okay, sir. See here, if the points are different, we can find the area of the triangle. Okay, sir. If the points are different in a different manner, we can find out the area of the triangle. The points are in linear equation. So here we cannot find the area of the triangle. Therefore, then, okay, sir, then this equation becomes 0. Then this equation becomes, if the points are collinear, then x1 y1 minus y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2 is equal to 0 for the collinearity. Okay, collinearity. Yes, sir. This is the two equations derived. One is center, okay, sir, in center of the triangle. Second one is area of the triangle. Okay, sir. It has taken some more time. Sorry for delay and, okay, sir, the latest, okay, sir, delay and lengthy derivation. Okay, sir. It may be, but here I am sure what I given the accurate. Okay, sir. What are the every step by step derivations? Okay, so. For the lengthy classes, I am going to conclude this classes on the we will meet in the next class. Okay, students. Thank you for watching.